we want to talk about reflecting a point through a line. So I've got a point and a line here, a point and a line here, a point and a line here. To reflect a point through a line, I've got the two rules here. I'm just going to demonstrate them, then I'll read the rules to you. The idea is fairly simple, but it can get a little confusing when you try to eyeball it, so we want to be careful. Okay, so to reflect this point through this line, we first sketch a projection line. So I'm going to call this the line of reflection, and I'll abbreviate that just for the in the interest of time. And this is the projection line, the dotted line. The projection line has to make a right angle. So the projection line basically goes straight through. If you're standing here and here's a fence, and over the top of the hill you see a mad bull coming at you, this is the direction you're going to run. You're going to run straight toward the fence, which means your path is going to make a right angle with the fence. That's the shortest distance between you and the fence. Okay, so there's your right angle. The other characteristic of the reflection of a point, and let's give this point a name. Let's call the point A. The reflected point has to be at the same distance from the line as the original point, and I should add on the other side. Okay, so it has to be on the other side of the line, because if it was on the projection line on the same side, then it would just be the same point. Okay, so we have the point that we'll call A prime, and this distance is the same as this distance. So I could say that these are equal distances. Okay, that's the rule. Now, I could have stated these things a little more specifically, a little more rigorously, but your book gives you a good rigorous definition. That's the idea. So how would we apply that idea here? You should pause and do this. But if this is the point, call this point A. I draw the projection line, which has to make a right angle with the original line. And of course, I haven't said it, the projection line has to go through the point that you're reflecting, as it did over here. And then you go an equal distance on the other side. We make sure that this is a right angle. This angle should equal this angle, and this angle, and this angle. All four of these angles should all be equal. If they aren't, then you know you excuse me, haven't drawn a good reflection line. Then we go the same distance from here to here. So here's my point A prime. I could note that this distance is equal to this distance the way I did here, but I'm going to leave it the way it is. So we have equal distances along a projection line, a line at a right angle to the original line. So they'll call this the line of reflection. Okay, so can we do it here? Okay, well, this gets a little trickier because I'll see people wanting to do things like this. Okay, what's wrong with this? Well, what's wrong is that the reflection line's not at a right angle. This angle and this angle are very different. These angles would have to be the same if this was a right angle. Okay? So that's one example, or straight down, or in the direction you went on your last construction. Okay? But we don't do that. We make the projection line at a right angle. So at a right angle with this line, that means we have to, let me kind of block the picture here. I'm already doing that, I know. can't seem to make the line straight. Okay, well, that's my attempt at a good projection line. That's a right angle, which means that all the others would also be right angles. So here's my point A, here's my projection line, and I have to go at an equal distance on both sides. So point A, projection line, equal distance means I got to go this far on this side, and that would put me here. So here's my point A prime. So whether the angle is vertical, horizontal, or at some angle with vertical or horizontal, you should be able to make a projection line. And if you want to make it really neat, you can take a piece of paper and measure that angle. And again, I'm kind of in the way there. Okay, take a piece of paper and insert it here to see if you've got a pretty good right angle. Now, I did a little better than usual on that one. I didn't have a lot of confidence, but it turned out that it came out pretty good. Okay, that's how we reflect a point. That's the basis of reflecting shapes. Okay, now we want to talk about reflecting a triangle through a line. So I have a triangle here and a line, triangle here and a line. Okay, to reflect the triangle through a line, the easiest thing to do is reflect each of the vertices through a line. So we take this vertex, we sketch a projection line, and we have the image of the vertex. Okay, so let's just label these points A, B, C. So we could label this vertex C prime. We could reflect B. Okay, again, right angle, equal distances. And we could reflect A. Okay, now distance is here. Distance should be here, so that the point should maybe be here. Okay, so each of these 3 points has been reflected. So now we have points A prime, B prime, and C prime. And we can connect the 3 points, and now we have a reflection of our original triangle. Again, the projection lines have to go at right angles, and I really recommend that you sketch the projection line, sketch the right angle, the symbol for the right angle, and if you don't have a good right angle, erase it or start over and draw the projection line at a right angle to the line. Okay, and you want to focus on one point at a time. You don't want to try to see what the reflection of the whole thing is going to look like and try to make everything work so that it looks like you think it's going to look like, although it's fairly easy in this case to do a good reflection. You want to go point by point. So you want to do point A, point B, point C, and then connect the 3 points. So let's say we have this triangle. Here we have A, B, and C. Let's reflect point B first. Okay. Now we've got to go at a right angle. And actually I'm going to start with point A. Okay. We've got to go at a right angle to this line. Now it's a little harder to do when the line is oblique, when it's at some angle. If it's vertical or horizontal, then your projection line will either be straight across or straight down. Okay, so and it's a little hard for me to see here, so I'm probably not going to do real well. But let's just try. Just imagine I'm here and there's a bull chasing me. I'll go to the fence. Okay, so maybe that's a good right angle. Then I've got to go an equal distance. Equal distance. So I'll have the point A prime, and then I'll do the same for B, and the same for C. Extend this a little bit, then we'll try to get the right distance. So it's going to put us about here. So here we have the point C prime, here we have the point B prime, and now we can complete our picture. And it didn't turn out real well. This triangle is a little fatter than this one, so I didn't get my distances exactly right, but you understand the process. And if you do these freehand, you're probably not going to get all the distances right either. We could have measured these and come up with a really neat and really pretty precise projection, but just eyeballing it, you're probably not going to do a whole lot better than this. Actually, you might. You might well if you're careful. Okay, so that's the idea of reflecting a triangle through a line. And we'll proceed in the next video to make reflections of shapes or reflections of groups of lines. You'll see.